Hello friends, welcome back to the bench. Our patient is a Surface 5 laptop model 1979. Now I have never worked on these before, although I've had so many inquiries regarding the unlocking of the BIOS on these. And now I do have like extensive diagnosis from a friend that sent us this, but I'm not gonna use it. I'm gonna perform my own diagnosis as if I don't know anything about it, and especially since this is the first this kind of laptop that I'm working on, and I have no board view, no schematic. So we're gonna have to use the knowledge we acquired from the schematics and board views of similar machines, and then I'm just gonna use our senses. Now, compared to Surface Pro 5 tablet, it's significantly bigger. It's bless you. It's pretty much the same thickness, but obviously the screen is separate, right? So the screen is nice and thin, and on this one we don't have to take off the screen, so the disassembly procedure is a lot easier. What does it do? Well, when we connect the power, the light goes off, right? It lights up. So there is something on the other side, but there's zero current draw, and the power button doesn't do anything. Now it could be that the keyboard is not connected. Maybe it is disconnected. We'll see, and that might be the issue here. There was a screw that came with it. It's right here. And I suspect that this is the screw that holds the SSD in place. And the screws over here are missing. But this assembly is pretty simple. You just take off those little legs, 4 legs, and that reveals 4 screws. You remove the screws, and the top should dislodge. Let's see. There. Yes, so the keyboard was not connected. That's why there's no signs of life from it. So that's good. Yes, the SSD is unscrewed, so that's what the screw was for. And let's see, shields are in place. We have few stickers over here. So since it doesn't, let's see, is the battery connect? Oh, the battery connects from the bottom. So the SAN chip is going to be on this side. Here we have the big shield for the CPU. The speaker position is weird. It's not right by the edge. It's far from the edge. That's unusual. That is indeed unusual. Looks like the left speaker is damaged slightly. Looks like it's damaged by the screw. So this is actually pretty common because the speaker has a permanent magnet in it, and it will catch the screw. And if you don't notice it and you put the cover back on, you're gonna damage the speaker. These are very interesting speakers too. Well, the battery is not charging when we connect the charger. So that's the issue number 1. Is it a damaged battery? Could be. Is it the damage on the SAM chip? Could be as well. So let's connect the keyboard and see if we can boot it. Nope, no signs of life. 0. It's dead. Okay, but since since the light goes off on the charger, that means that there is something on the other side, right? If it was like completely dead due to a blown fuse or something like that, we would not see the light on the charger. Mainly because we have no schematics, so that is gonna be more difficult because we don't know where to measure. The heatsink needs to go off first, and those RF shields, I do not like these because they're so difficult to take off. Looks like a plastic spodger, I think. I don't know. Piece of plastic. It was underneath the fan. Interesting. Looks like I'm not the only one who struggles with these RF shields. Okay, we have access to 1, 2, 3 coils, 4 coils. So one of these should be V-core, or V always on. The primary voltage, which is roughly 15 volts. Without that voltage, the computer will not boot because nothing else, and it will not start charging either. That's where a schematic would have been very useful. Now I'm contemplating whether to take off the screen so I have easier access to everything, but before I do that, let's remove as many shields as we can and gain access to as many components as we can so we can assess. Okay, so this shield revealed the actual coil I was looking for. So these 3 are probably V-core for the CPU. So this is our main coil. This is what's going to be charging the battery. I would say that this is SAM. That's our main input resistor. So it looks, so far it looks relatively similar to tablets. Yes, so here we have the 2 MOSFETs driving this coil. This MOSFET turns on charging. Here we have the BIOS. The BIOS chip is here. If there is password on the BIOS chip, we should be able to fix it or to remove the password. So let's do some measurements. 12 ohms. We have 12 ohms on this coil. That doesn't seem normal. Let's see, V-core. Yeah, we have 8 ohms on V-core. That is correct. Alright. 115 on SA. And 18 on I/O. So the CPU is fine. It's not fried. But 12 ohms on this coil, that doesn't seem right to me. That's why it's not charging, because charging will be going through this big coil over here. There should be roughly 8 volts when you when you plug in, it should be roughly 8 volts, 8.5 on this coil. Now this coil gets its voltage well, first there's a linear regulator, or a highly efficient linear regulator, or a switching regulator that supplies EC chip. Then the EC chip delivers or turns on this circuit. Right? The EC is likely this chip. It's usually close to, well, actually not usually. On Surface Pro 4, it's on the other side of the board than the BIOS. Now we know we're not gonna have, because without this coil, we're not gonna even have the power on. Oh no, actually, let's check that, because I'm kind of using the knowledge from other devices, but this might not be the case. Let's see. I don't remember which pin, so let's check them all. There should be 1.8 or 3.3 on one of these pins. Now we have negative 26 millivolts here. That's weird. Yeah. So we have no supply voltage for the BIOS, but that's fine, because it's the EC chip that will supply that. Now, which one is the supply voltage to the EC? Because we should have an EC VCC. Without EC VCC, the computer is not going to turn on, because there's nothing to turn it on, because it's the EC that turns it on. Now, how do we check the voltage on EC without the schematic? It's gonna be this big cap, and we have nothing. So, see, the short we could fix without the schematic, because we can just inject voltage and see what's getting hot. And maybe that's something that we can easily replace or not. But I don't see any signs of shorts, so this will be difficult without schematics. That is too bad. You know, the power on sequence on these these machines is relatively complex. There's like 5, 6, maybe even 8 different signals that need to go either high or low for the EC to actually turn on the device, or for EC to even be powered. And the reason behind that is that if there's anything shorted or there's any kind of fault, that it should not turn on, right? If you know this sequence, if you have the schematic and the board view, and you can find all the components on the board, you can force that signal, right? You can just supply a PG signal to the EC and see if the EC will turn on the board, right? That way we know that the problem is in lack of PG signal. But in this case, your guess is as good as mine, how to, or where the issue might be. The typical faults are, you know, if you measure on the coils and you have shorts, well, that's your issue. But the only thing that is suspicious here is the resistance on this coil. Lower than I would expect, but 12 ohms, that's not short. Yeah, so if this was, so this is what was reported on it. It boots to the Windows logo. It doesn't go into BIOS, and it gets stuck on the Windows logo. And when you remove the SSD, it behaves differently. I don't remember at the moment what the issue was, but that was the issue. So I figured, if it's a BIOS issue, I even downloaded some unlocked BIOSes. So all we gotta do is just rip the BIOS off of this one, decompress it, and replace the BIOS region. Flash it back, and we're done. The password is removed. But for that, the computer actually needs to work. Now there was a suspicion of a corrupted BIOS, right? Because I think the firmware update was run on it, and that's what caused the issue, or that was run in an effort to fix an issue. And so I suspected that all we gotta do is just restore BIOS on this, and we'll see. But the computer needs to turn on for that to be the case. Now disconnecting the battery would be a good thing, but unfortunately this is one of those awesome designs where the battery connects from the back. So to disconnect the battery, you have to disconnect the whole thing. Pretty much everything. So we need to take off the screen, take off the board, and that's how you disconnect it. But I don't think that would make any difference. I just had an idea. So this should power on through USB-C. It negotiates the voltage, right? 20 volts. But it's still not grabbing any power. Okay, so I assume that this is the power management chip. This is its output. We get 20 volts here. That 20 volts travels to this little guy, right? And I assume this would be the output, on which right now we have negative 38 millivolts. This is open drain. It looks like it's kind of jumping around a little bit, but it could be just my leads. So fault protection is not triggered. We need is pin 5 enable. So the second one from this side, and it will turn on if this pin is low, and it has 2.6 volts. That's why it's not turning on. So that's why the computer is not turning on. This switch prevents it from switching on, and it is conscious decision to not turn it on because 2.6 volts is supplied. Where is this signal coming from? We don't know. Now, so the hunch was correct, right? That this is a switch and it's not turning on, and it should only switch one side to the other. So we could just trigger it, meaning just create a short between those two points and see what's gonna happen. But again, that is still pretty risky, because the computer is not turning on because it detected some kind of fault. Nope. So even if I short it to ground, I still don't have the 20 volt output. Which is weird because I do have what was it, 2.6 volts here, right? So it's not like this chip is damaged. It's performing what it's supposed to be performing. It's not turning on because the enable pin is not high. But even if I make the enable pin low, it's still not turning on. Okay. So when I short it, I do get the voltage on this resistor. And this is likely our input here. Then this transistor opens, but no voltage on here, right? No voltage on the coil. And that coil is likely controlled by these two transistors, but it might be that these are just transistors that open and close just to allow the current to flow through the coil. Could be. But I get 20 volts here if I short that one. Still no charging, but we get the sign of life on here. There's too much guesswork here. There's always a little bit of guesswork in every job like this. You don't always get the schematics and stuff, but the success ratio, or typically the successful repair, is when you find a short. Yeah, you don't need a schematic if you find a short, or if you find something that, you know, and that is easily fixed. In this case, the computer is not turning on because we have 2.6 volts on the enable pin. Enable pin should be connected to ground for it to open. Once it opens, then we get voltage on this resistor, and we can go from there, right? Probably this transistor is not opening, and again, it's not opening because something else is wrong. So without a clear power sequence, it's too much guesswork. So I don't think I can fix this one. I will continue kind of tinkering with it. Maybe I'll find something, but at the moment, it's, you know, technically we know roughly where the issue is, but there's no way to actually fix that, right? Because we don't know where this 2.6, even where this 2.6 is coming from, right? If we had a board view, we could trace it easily to see where it's coming from. But without the board view, there's not much I can do. And I tried searching for it, but I didn't find anything. Even on the websites that usually have stuff like that, you have to pay, but they have a lot of board views and stuff, and not even those. So probably Surface 5 laptops are not gonna be on my list of stuff that I repair. Although if you have a locked BIOS, I can fix that, but not electrical issues. Well, we're gonna stop here. I'm gonna continue tinkering with it to see if I can find anything, but at the moment this is gonna be no fix. Sorry. Well, in any case, I hope you guys found this useful. Thank you very much for watching. I do appreciate you, and I shall see you in the next one.